thanks for having me. And yeah, I want to kick off the last session here. Hope you all snacked up on a coffee and are ready to go for this Friday afternoon. The power of generative marketing. We kind of look at the phenomenon of images and generated images, how they pop up more and more in the marketing context. So we see that kind of magazines use generated cover magazines or even entire like print ads to foster them in their magazines. We see like generative AI being part of the product design process. Designers kind of playing around with it. It's like a crucial part of there. But we also see like a product design use case where it's just used for simple ads. For example, at the bus stop, you see this like advertisement here. And as well, we see a lot of UGC on social media, but also companies kind of playing with those tools. The question, however, is, like, do we really know whether this works in terms of marketing metrics? So, do we achieve the KPIs we want to achieve? Click-through rate, conversion rates, etc. And that kind of still remains an open empirical question. But before we get into that, maybe to just cheer everyone up, Friday afternoon, quick quiz. Which image do you think is one? First.
Bottom second left.
Bottom second left. This one? Okay. One more guess?
One above it.
This one?
Yeah.
Okay. The thing is, I'm not going to tell you yet, so you have to wait for a second. Let's do what a researcher would do when we have a question that we want to do. We do dive into the literature and look what's out there. We see there's like a lot of research in terms of human versus AI assessments. We talked about a lot of them. Actually, 3 of those 5 that I kind of put on the slide. We had a session today about. So we learned that kind of SEO content can be done, or actually SEA content in today's talk, to a level of human expertise or maybe even outperform humans with AI. We see that product reviews can be written with AI to an extent where they are not distinguishable from human-generated online reviews. We see that sales calls can be made much more effective, much more efficient, so there's like less managerial interventions. The average duration is shorter, and customers are happy with kind of scripted sales calls. And just in the previous call, we learned about those perceptual maps that they more or less look exactly the same in terms of whether they're made by AI or humans. And lastly, I discussed earlier how AI is able to mimic human behavior. This is the negatively sloped demand curve, state preferences. So in total, we kind of see there are initial studies comparing AI, generative AI, with humans. Very often, in terms of text, AI is quite there. So they get there, they maybe even outperform. But on the other hand, we couldn't really see a lot of images. And that's kind of the question we wanted to address. So, going forward, we looked at 3 studies. The first one was just very general, does it work? For that, we created images and asked participants or respondents how they perceive them in terms of quality and in terms of realism. So we used kind of benchmark images, so these were human-made on the one hand, and we created sibling images with AI that resembled more or less the same context, and then that way we asked the respondents. Now, answering the question whether it works, we asked ourselves, does it work in marketing? So we looked at one specific use case, social media, and asked our respondents in the lab, like how likely are you to like an image or how likely are you to comment on an image. And, again, followed the same approach. We had one original image and a couple of sibling images that were AI generated. And after knowing this, kind of getting some validity, we kind of aimed for external validity and ran a field study to ask whether it actually works in the real world. Does it work in the real world? And we ran a kind of online banner field experiment where we, again, compared the human image versus generated siblings. And we assessed the difference. To be independent of the specific models, we use 13 just like heterogeneously selected AI models, all of them diffusion models, and created images of this. And I think an important topic to mention here is that, of course, as these models evolve, it's more of a proof of concept or a conservative estimate, a lower bar for their performance as they develop even further. And in that spirit, we also didn't conduct any prompt engineering or and any other tweaks to optimize the performance by design. I talked a lot about how we kind of had these human images and we created artificial siblings. Let's dive a little deeper into this. So this is an example from study 1, and we created where we used 6 images from the marketing journals, just used them as our benchmark, as our human baseline, fed them through Clip, which is more or less an image and text tool, and then create or received a textual embedding, which was just a description of what we see on this page. The next step, then we use this textual embedding as a prompt for our diffusion models, which then generated these 6 images. That way, we kind of use kind of an intrinsic advantage of these diffusion models because Clip is actually being used in the forward diffusion process. So when you train a diffusion model, or most of these diffusion models, Clip is what kind of tells the model the connection between an image and a prompt. It's sort of a dictionary, and that way we make sure that in this step, as well as in this step, we use the same dictionary. On top of this, we kind of, as I said, we didn't conduct any prompt engineering, we didn't tweak anything on the image, we really wanted to have a lower bar conservative estimate, but we followed some image text alignment assessment as outlined by Google, and we ended up in a similar range, so kind of giving a little bit more validity to the fact that we actually accept images. Great. Then, with that, maybe jumping into study 1. Does it work? The question was how the quality and the realism of those images is. We had those 6 benchmark images we've seen before for product design, social media, and print ads. And we created for 13 models 20 images each. Actually, that's difficult to say this. 20 images times 13 models times 6 benchmarks. And per image, we then got like 5 ratings on a typical Likert scale. Like how do you rate the quality of this image? How do you rate the realism of the image? And here is just some exemplary stimuli, I think, just with the intention to show again, not all of these images are the ones that we would see like if we talk about AI, because we didn't conduct any prompt engineering or conservative. With that, looking at results. What we see here is kind of a model-free, just average per model of all these 20 images that the model created for the product design use case, where we have on the x-axis quality, y-axis realism. And as we've just seen the pictures, we were a little curious how good these images will be, but it turned out that for the product design use case, they're actually quite good. So we have the benchmark here with the triangle in here, and we see that a lot of models are, on average, over the 20 images, able to actually outperform on both dependent variables in both dimensions. And in the bottom case, we kind of get there, we outperform on realism, not really in quality, but we kind of get there directionally. And if we model this, actually, we learn that some of those outperformances are statistically significant in both dimensions. And hence, like AI is actually really able to outperform human. Looking into the second use case, social media, it's getting a little bit more tricky actually. Again, we have examples where it outperforms in both dimensions, at the upper right corner. However, here for the Corona beer example, like not entirely there, but we have 2 kind of clusters that are somewhat close by. Lastly, looking at print ads, there we're clearly not there yet, which we can only assume to our extent. It has a couple of factors. I think one is print ads are by nature very Polish, very sophisticated. There's like a lot of Photoshop involved, and also very often they include text, or like more text than the other images. So here, for example, or just like a whole section, which is a known limitation of the model so far. Other comment is that we learned that so these images can be on par with humans. They're not guaranteed to be on par or even outperform, and there's actually cases where so it's possible. The question, or I think the magic comes in when you know how you make sure to select the right models to then actually outperform. Interesting fact is that if you look at the bottom left part, you kind of see these are technically pink hues. So they're all like in the bottom left area, indicating that model choice matters. So we have models that consistently rank well, models that consistently rank worse, and we also see this flow of these things. Great. So now that we kind of know it can work, we look at marketing. At the marketing use case, we use one benchmark image, one human image, and in this case only 13 other models and pictures. And these 13 pictures are the ones that were ranked the highest in the realism scale here before. So we just selected one rather than the 20 per one. Kind of indicating an intrinsic A/B testing, which is something you would likely do if you would apply it in the real world. And again, the user interface asks the respondents what they think on a Likert scale from 1 to 7, in terms of likelihood to like an image and in terms of likelihood to comment upon an image. Now, I promised you an answer. Whoever listened carefully might already know which one is the human one. It was shown twice. Any ideas?
Bottom third.
Yeah, correct. That's the benchmark, and my last quiz for today is which image do you then think is the most likely to be liked, based on our research? That's tough, okay. So, turned out this one, kind of hard. Next one was this, followed by this one. So I think like there's some base level of quality, kind of what you would typically see. Images like here where you probably from training still have the Shutterstock image or so, would probably not be sure. Great, looking at examples. We learned that 6 of the 13 AI models are kind of on par with the human. So we have here the whisker plot. The the Y 0R refers to the human benchmark. And 6 of those 13 AI models are statistically not distinguishable from the human. And 3, achieve a directionally higher mean. Again, the same models than before are kind of in the lower performing section, so model choice matters. Similar to study. Looking into study 3, now we kind of look for external validity and assessed with a real-world consultancy or a sustainability consultancy who provided us with one stock image that's this one. And we created 13 synthetic images. Actually, 13 times 20 again. We selected the most realistic image, just as before, to mimic our A/B testing. Ran it through online banner ads and received the results. Turned out that the human only ranked number 10 out of 14 in terms of the click-through rate, which was our dependent variable. So, like, pretty amazing in my thinking, with over 85,000 impressions. So, kind of high end. However, if we assess this on conventional alpha levels, it's not significant, kind of close, but at least we have a 21.5% higher click-through rate for the best performing model versus the human. And lastly, one more time, model choice matters. This is again significant. That's the best and the worst performing models are statistically significant better than the worst. So, what does all of this mean? I think I mentioned before, it's a lower bar. We didn't conduct any prompt engineering. We just let the models be how they are. Therefore, the pictures are not perfect. But it kind of, with this, argues for a first-time proof that images can be at least on par, and sometimes are even able to outperform humans. Just without any human intervention, no human in the loop. And if we pair this with a lot of things we learned today, that AI is cheaper, AI is, in a sense, like you can build an autonomous pipeline. Hence, you could build a more cost-effective, more efficient pipeline with just leveraging A/B testing and just building this at scale. If you do not include a human in the loop. Alternatively, you can just run the other way, and I think that way you're even more likely to get good outcomes. This, I asked GPT about Stable Diffusion what they think of our workshop based on the website. That's what. Thank you very much.
Thank you.